Hello everyone, you are all welcome to this platform of our online GS training, where we are going to be sharing ideas on how to solve different spatial problems based on experience and the knowledge that we have acquired so far. So we'll start by looking at how to answer the five basics questions that GIS tends to answer, particularly the question of where is what we're going to be looking at, because what makes GIS differ from other information systems is the spatial content which it gives consideration to. And for us to solve that particular problems, there is an operation that we use to perform on any data that we are bringing in order to model the real life situation in computer environment. One of these processes is called georeferencing. Georeference. It's make up of two words, the geo and the reference. That is, you are bringing the earth surface into the computer environment. You want to be making reference to what is really on ground. So for us to do that, the software we are going to be using today is one of the softwares in ArcGIS suites, and the name is ArcMap, if you can see it from here. For those of us that doesn't have it launched, you can always find your ArcMap somewhere around this place. Just type search it, you see ArcMap. You see there, I'm using 10.6, whichever version you're using, you're welcome. So the data that we're going to be using is located somewhere inside my drive C. I usually advise people to get their GIS project folder under their drive C. The reason being that if you give your system out, or you allow someone to access your computer, it is easy for anyone to come to desktop, document, download music, picture and the video, but it only takes a certain level of experts or IT knowledge for someone to come into this part of your system to access this portion of your system. So in lieu of that, I prefer keeping my folder, my project folder inside my C drive, because in GIS every work we do comes in files. Like now I'm having two files. These two files, by the time I started working on this file now, there will be an additional file will be creating over the process, and if any of those files miss, it means something will be wrong with the project folder particularly, or with the project. So I have the topo sheet of Cesarea noticed, and I have the coordinates which I've given some touches. So on this interface, there are 7 ways by which you can add data into this environment, 4 of which were normal, 3 of which are abnormal. But before we go to that, when you look at what is displayed here, what is displayed here is the coordinate of this interface. But you can see it's writing unknown units. What the software is telling us is that before we can make use of this as a surface of the earth, there is need for us to have a reference point. What I mean by a reference point, we can also call it a reference ellipsoid. How do we want to, the model of the earth, how do we want it to look like? What would be the type of ellipsoid we want to adopt? What would be the major axis, minor, semi-major axis rather, semi-minor axis? What would be the flattening of the ellipsoid that we want to represent the earth surface with? So for us to solve this particular problem, the first thing we need to do is to set a reference ellipsoid for the earth surface that we want to be using. So for us to do that, we can right click anywhere on this canvas. You see data frame properties. When you click on the data frame properties, another pop-up window will open from where we can specify which ellipsoid do we want to make use of. And under the data frame property, our major concern is the coordinate systems, because it is the coordinate system that accommodates or that house these the datum for the reference ellipsoid of desire. Broadly, we have two classifications of coordinate systems. The first one is geographic, and the second one is projected. The geographic is often used when the work is on a global cases. That's when your project is very large, and the accuracy desired is not of high standard. Majority of time, that's why you make use of geographic coordinate. But when you are taking it to a locality where there's need for a much more higher accuracy, then the projected coordinate is preferable. And in this kind of projected coordinate systems, we make use of zones. Another thing I would like you to know is that whenever you are working on a project, that the zones that the project site cut across is more than two, or is more than one rather, it is advisable for you to make use of geographic coordinate system. When you reach a certain level of professionalism, you'll be able to know how to use projected coordinate system even if your project site cuts across more than two zones. So under this geographic coordinate system, we have a lot of them. We have a lot of different reference ellipsoid. We have different kind of coordinate system underneath, but the one that we're going to be using today is the World WGS of 1984. Does WGS means World Geodetic Systems. If you look at this is the one we are going to be using. Let's check. Can you see? Just look at the last digit of the flattening and the semi-minor axis. Look at the last digit. If I should pick this, those value would definitely change. Can you see that? It means all this coordinate system here, all of them do have the same parameter. So whichever one you are using for your project, you should be very vigilant of what the parameter are, so that you won't mix it up. Like WGS 1984, you can see we have series of them. You'll be surprised the parameter will not be the same in some instance. You can see that. So we are going to be using this for now. Then after we select that, then we can now apply, then we now okay. You can see this thing has brought up a unit, which is decimal degree. Now for us to bring in data to this environment, we have a map, we have a topo sheet of Zaria Northeast, and we have the coordinate of that file. So I want to bring in the map. For me to bring in data is either I make use of this button, it's called add data, or I come to this layer under the table of content, I right click, you see add data. Another method is for me to come to file, I'll see add data, whichever one you use, it's a go. So once I click on that, it will automatically navigate me to where I worked last. So for those of us that we have our ArcGIS and stuff fresh, you can just come to the folder connections to see those folders that are available. So you might not have any of these available here. So for you to now connect to your drive C where you put your project folder, you come to this connect to folder. So under the connect to folder, you look for your drive C. My drive C should be under this PC. So this is my drive C. I'll just select, you see C column backslash. So I'll just say okay. So the reason why my own is not automatically showing everything under my drive C is because I've already added it. So if I should click this drive C, you see this is everything under my drive C. So I'll just pick online GIS training. So under the online GIS training, I'm having Zaria Northwest JPEG format. So I'll just select this, then I'll now say add. The same is processing it, you can see it here. So now peradventure there is a step that is being skipped because I've given that option to be automatically doing to carry out that operation. The operation is a build pyramid. A pop-up window might come up before this one where you are adding your own, asking you to build pyramid. It's very important that you pick yes to build a pyramid. The essence of the building a pyramid for your data is for you to improve the responsiveness of your data. That's where you are zooming in, where you are zooming out, where you are dragging, so that your data will be responsive quickly. So for this, it's telling me that the data I'm bringing in doesn't have any spatial reference or no spatial reference. That is, it's not representing any place on earth as the geographic information is concerned in this area. So what I will just do is I will say I agree with you. So what the software automatically do is that it will take your data to the equator. In as much as it doesn't have any spatial reference, it will just take the data directly to the equator. So you can just imagine this coordinate display for this small map. So let's see if I should look at the corner of this this map. You can see the coordinate of the map itself, and you can see what this one is displaying here. So if you look at this unit of this coordinate is in degree minutes, and this one also is in degree minutes, but the display coordinate here is decimal degrees. How do we get from degree minutes to decimal degree? What we used to do is we'll divide the minutes by 60, because 60 minutes is equal to 1 degree. So we divide 60 by the we divide this 30 by 60. So whatever the result is, we add it to this, so it will give us the answer for this place in decimal degrees. The same thing applicable to this. As we have this corner, so do we have other corners too. So the same thing that we do for that, we can always do it for the other corners too. You can see. So if you look at the the coordinate file that we have here, this coordinate file, I've already done that for us. Sorry, I've already done that for us. Have organized that. So what I did is that I did the coordinate capturing and conversion in a clockwise direction. So the first one here, if we divide the 30 by 60, we are going to have 0.5. 0.5 plus 7, that will give us 7.50. The same thing as this, if we should divide this 30 by 60, we are going to have 0.5. 0.5 plus 11 will give us 11.5, of course in decimal degrees, from degree minute to decimal degree. So the same thing applicable to these other corners too. If you look at what we have here, we have 7 degree 45 minutes. What I did is I divide the 45 minutes by 60, which is going to give us 0.75. So 0.75 plus 7, we are going to have 7.75, and there is 11 degree 30 minutes. We've already done that before, so we have it to be 11.5. So there's something you should note here on this coordinate. If you look critically, you see that 2 of those coordinates in Y are the same, and 2 of those coordinates in Z are the same. So the reason being that is that if they give you the coordinate of this corner, the coordinate of this corner and this corner, you should be able to generate for this corner and this corner. So that's the implication. So another thing that I would like to call our attention on is the issue of X and Y here. You know, majority of time the people used to think the horizontal axis is our x-axis, and then they put that, and the vertical axis is our y-axis, but majority of time if you look at it, this vertical axis is our x-axis and the horizontal is our y-axis. Let's quickly take a brief look at that. Assuming this line here, this particular line, assuming it is x, and they say the value of this value of this line is this. So by the time we are moving here, this particular line is still the same, which is the y. It's still the same, but this one is increasing as we are going this way, and whatever this value is here is still the same. What is it here? And the same thing applicable to this. Whatever this one is here is still the same here, but we are moving across. But by the time we are moving upward, whatever this value is here is still the same thing here. Of course, it's on the x. By the time we move up, we are going to have this. Whatever this one is here is still the same value here. So you can see the y is increasing vertically, and y our x is increasing horizontally, but that line still remains the same all through, from here to here, from here to here. So if you need any more explanation about that, you can leave your comments on group. So now the next thing for us to do now is for us to carry out the geoprocessing, and for us to do that there is need for a tool. Or before we even do that, let's bring in these are xy data, which is the coordinate. But please don't forget to look at the way I formatted this. I formatted it in a way that we have x comma y. Whatever the x is, you type it irrespective of the point, then you put comma, then you type the value for y2. Make sure you follow this pattern. It's very important for software to see it. So after that, the next thing we are going to do is to bring in that our coordinate file, and for us to do that, you can always come to file, add data, add xy data. So this is the add xy data. That's another way by which you can bring in data. This particular way I'm showing you is still the same way you can bring in Excel data that has longitude and latitude, or that has eastern and northern, no matter the number of coordinates, whether your coordinate is in meters or is in decimal degree or is in degree, minutes, seconds. So the coordinate system that you are going to pick and the display unit will determine how the software will see it. So just note that. So for me to bring in that file now, that coordinate file, I can always browse, click here, this is my file, so I'll just pick it and I'll say. So you can see this one has automatically see the x field and the y field. There may be a situation whereby there was a mix-up. The field that's supposed to be for x is y, so you can always interchange it and make things right. But here we did the right thing, so x is x, y is y. Under this description, sometimes might be where you're going to have it as a unknown spatial reference. So it is your responsibility to set it to the coordinate system you're working. It is very important if it's writing unknown spatial reference. So you just click OK. But by me looking at this, I was already inherited the coordinate system of this interface, so there's no point in doing that. Then we'll click OK. This grammar, forget it, just click OK. Then we have the location of our map. This is where this big map is supposed to be. You can just imagine this whole map is supposed to be in this small place. By the time I right click on this coordinate point and I click on zoom to layer, this is where the map belongs. This is where the map is supposed to be. So now the next thing for us to do is to bring out a tool to move this map into this small place. So to do that, you can always come anywhere here, just right click, you see a lot of extensions, then you look for georeferencing. My own is checked. If your own is not checked, you have to check it to have access to it. So once I check it, you can see I'm having it here, and these are the modules on it. So for me to start tying the points, I would like to show us one thing that is very important. This auto adjust must be turned off whenever you are trying to georeference, particularly when the accuracy of what you're doing is required to be a of a high standard. Because what this auto adjust used to do is that if you had 2 points, at least we need the minimum of 4 points to georeference the map using first order polynomial. But what this auto adjust used to do is that by the time you add the 2 points, it will add the other 2 points for you automatically, which majority of time might not be correct. So it is advisable to turn it off. But there are situations whereby you have to turn it off. I mean, turn it on rather. That's when you have a lot of maybe it's tiles of satellite image to georeference and the likes, and so it's just depend. It's a choice, but I will advise you to turn it off rather when your work require higher accuracy. So I would like us to turn it off. So the next thing for us to do is to start adding control points. You can see that my cursor has already changed. So I will now zoom to the point of intersection of these two lines. I'll zoom to a pixel level because majority of time whenever they scan a map, it comes with certain level of error, and to correct that certain level of error, you have to zoom to a pixel level to get exactly where the point of intersection is. So I'll pick this place as my own point of intersection. So once I pick that, I'll come back to this coordinates file. I'll zoom it to layer. The first point I pick is top left corner, then I'll tie that point. I'll zoom back on the image, zoom to layer. I'll come to the corner. I'll zoom to the pixel level as well. If you can see this, sorry, there's something I need to show you here concerning the error I was talking about whenever they do scanning. You can see this line has already been cut off. So to correct this kind of error now, you have to zoom to a pixel level to get exactly where the point of intersection is. So I'll pick here, then I'll zoom the coordinate back to layer. I'll tie the points. I'll do for the remaining other corners. So we have our corner here. I will also zoom this one to the pixel level. I think this one we only have one pixel at the center. Then I'll pick it. Then I'll zoom this one back to layer. I'll tie the third point too. So the same process for the 4 points. The same process, nothing changes except the location of those points. This one too to pixel level. You can always take your time to do that because nobody is rushing you. So whatever you do here will be the basis upon which the accuracy of your work will be based. Because if what you georeference is not right, there is no way the error will be accumulating, and before you finish, you just see, particularly when it's solving work, you just see that maybe you are going to have more than a meter error at the end of the day for everything that you digitize. Now imagine at every 100 meter there's an increment of 1 meter for like let's say 50 kilometer. You can just imagine how much the error has accumulated. So after I finish tying the fourth point, then sorry, my system is I think there's a lot of thing on it. Sorry, it should soon come up. Now we have it. So I'll just zoom back to the map. So this is the map. I've already tell all these 4 points where they belong. So the next thing I will do is for me to come down to this georeferencing and now say update display. Once I click that update display, wow, the map has disappeared. Where did it go? it has gone to where it belongs. So if I should zoom this point to layer now, you find the map with it. You can see. So we have our map where it belongs. So the next thing I will usually advise is this cursor, we have to change it so that we will not be mistakenly click anywhere that we are not supposed to click. So how do we do that? We come to this select element, you click it, so it will return our mouse to the normal. So after we have this, so the next thing I usually advise people to check on is the accuracy of what they've georeferenced. And how do we do that? There's what we call residual. Here under this view link table, by the time you click on this link table, you'll see the residual of your work, how perfect your work is, what are the error in what you've georeferenced. These are the residual for X. You can see it's very minimal. These are the residual for Y. They are very minimal as well. So, and these are the grand residual. They are also very minimal. So it means with this we are good to go. So now after we've checked that and we are okay with the level of error that we have, then we can now say update georeferencing, and we have our map georeferenced. For us to check whether what we did was right or what we did is right, let me uncheck this. So then we will now look at a corner and check, we correlate the coordinate of that corner with what we are going to have as a display here. Look at this. Is it correlating with what that coordinate is reading at all? 7.5, 11.5. Do they correlate? Then if they do, then it means we have our map georeference already. So georeferencing is one of the bases, is the base upon which whatever you're going to do in GIS rely on. Although majority of the data we use in GIS these days, majority of them come with georeference, but there are situations whereby you need to re-georeference. So with this, I believe you will be able to answer the question of where a particular thing belongs. So we are going to stop today here. So if you have any question, you can forward it, and I will be giving out another topo sheet so that we'll have an hand-on experience on how we can extract out the coordinates the way I did, and how we can use that to georeference the map. Thank you for your time.